We are almost at the finish line with our current example. A few more things to sort out. So let's connect the remaining dots and perform some improvements.
Now it's time for a solid check. Let's remind ourselves of 5 principles. Those are single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Now let's review our code and try to identify some faults or celebrate a good quality. We'll start with single responsibility principle. It suggests that a code entity should have a single responsibility. Let's look at our data objects. Our application is pretty small. We could create one data class and put all the necessary information as properties in that class. Then we could use it throughout the whole application. Instead, we created 3 different classes and use them individually only with data that is necessary for specific part of application. Nicely done! Next in line is open-close principle. It suggests that code entities should be open for extension and closed for modification. Now it's your turn to review the code. Pause this video and try to identify parts that follow this principle. Welcome back! Have you found any? Perhaps extensions are a very good example of following open-close principle. Next in line is Liskov substitution principle. It suggests that subclasses should not modify the original capabilities of a superclass so that it's not usable in the context of superclass. This is interesting, and it's your turn again. Pause this video and try to identify parts of the code that violate this principle. Welcome back! Have you found any? Perhaps they aren't. Congratulations! Nicely done! Next principle to review is interface segregation. It suggests that the interface should implement only necessary capabilities for particular context. Thankfully, we kept our code to the minimum and implemented only the necessary parts. Or did we? And the final principle to check is dependency inversion. It suggests that a code entity should depend on the list number of other code entities. A good part of our project to analyze is media service class. Our project is quite small, and it's used as an example to explore the essentials of networking capabilities. However, along the way, we've built a number of traps for ourselves. The same class is responsible for dealing with particulars of media object, performing networking itself, parsing all the data, and on top of that, fetching images. That might be a violation of dependency inversion principle. This very same object also violates single responsibility and interface segregation principles. In larger projects, typical configuration would be having separate classes that are responsible for networking, for creating requests based on abstract parameters, for object-specific communication, and for parsing data. Now think about how you could change this part of code to improve the quality of the code architecture. It is all in your hands now.
Congratulations on fantastic progress! In this course, we work with new aspects of an application. Learn to work with collection views and practice networking. You also now know how to handle app requirements that may come in different forms and shapes. Those will definitely be valuable additions to the collection of your development equipment. Knowing the basics is a necessary starting point to continue exploring those concepts and elements in depth, as well as expand your knowledge. Keep learning!